A-level paper from October 2021. This is paper 1, so we've just got pure maths. As ever, we start with our formula sheet and then straight into question 1. So it says determine the set of values of k such that that equation has 2 distinct real roots. Now you should be looking at 2 distinct real roots and you should be thinking, you know what? I know what that means. That means b squared minus 4ac is greater than 0. And we're going to start with that. So identifying a, b and c. A is 1, b is 4, and c, they've even bracketed it for you this time, is k plus 3. So let's have a look. Pop that into the discriminant. So b squared, we're going to have 4 squared minus 4 times 1 times k plus 3. 16, then you've got minus 4 times 1, it's obviously minus 4 times k, so I've got minus 4k, and then minus 4 times 3 would be minus 12. Is less than, it's greater than 0. What we're going to have then, we're going to have 4 minus 4k is less than 0. So 4 is greater than 4k, so we can flip that round. K is less than 1. That's our set of values that has 2 distinct real roots. Make sure you watch out for your signs, make sure you expand that bracket correctly. Alex is comparing the cost of mobile phone contracts. Contract A has a setup cost of £40 and then cost 4p per minute. Contract B has no setup cost, does not charge for the first 100 minutes and then costs 6p per minute. Find an expression for the cost of the contracts in terms of m, where m is the number of minutes for which the phone is used and m is greater than 100. So it's just saying that you have got 40 plus 0.04 m. And then the second one is the number of minutes, take away 100, multiply by 0.06. So that's a vile question, 0.06 m minus, is that 6? Let me just double check that. 0.06 times 100. Yeah, that is 6. That's a revolting question. It then says, hence find the value of m for which both contracts would cost the same. So let's make those equal to each other. 40 plus 0.04 m is 0.06 m. Take 6. 46 is 0.02 m. So m is 46 divided by 0.02 is 2,300 minutes. That's a long time to be on the phone. Question 3. It is given that x is proportional to the product of the square of y and the positive square root of z. So x is proportional to, so from GCSE, remember x equals k, the square of y, so that is not y square root of y, it is the square of y, so that is y squared square root z. Right equation, so we're going to pop all that information in, so we've got x is k lots 2 squared root 9, so 30. 2 squared is 4, root 9 is 3, so 30 is 12k. 30 over 12, which is 5 over 2. So, therefore, x is 5 over 2 y squared root z. Feels very much like a GCSE question. Find the value of x when y is 3 and z is 25. So then part B, x is 5 over 2, 3 squared, and root 25. So let's just stick that on the calculator while we work that out ourselves. So we have got 5 over 2, 3 squared, root 25. It's 225 over 2. Excellent. It's been a really boring paper so far. Let's hope it gets better. So question 4. Cubic polynomial. This is a pretty standard question. Seen lots of these before. So use the factor theorem to show that 2x minus 1 is a factor. So what do we know then? Well, if 2x minus 1 is a factor, that implies that f of a half equals 0. So let's try that. So therefore, f of a half is 2 lots of a half cubed minus 3 lots of a half squared minus 11 lots of a half plus 6, which is 2 over 8 minus 3 over 4 minus 11 over 2 plus 6. Let's fire that in the calculator. So 2 over 8 is a quarter. So I've got positive 2.5 minus 0.75 minus 11 over 2 plus 6 is 0. It says detailed reasoning, so it's important that I have those lines with working out on them and showing that I have actually done some calculations. So therefore 2x minus 1 is a factor. Express f of x in fully factorised form. So let's get the quadratic factor first, and then we'll investigate to see what kind of thing we need to do with that, remembering detailed reasoning. So we want 2x minus 1. We've got 2x cubed, so that's going to be x squared. That's going to be minus x squared. I need minus 3x squared. So I need to have another minus 2x squared. That divided by that is going to give me minus x. That's going to give me plus x when I multiply. I need minus 11x, so I need that to be minus 12x. Divide that by 2x gives me minus 6. And then minus 6 times minus 1 is positive 6, which is what we had. So that means we have divided it correctly. So therefore, f of x is 2x minus 1, x squared minus x minus 6. Now let's investigate to see what kind of solutions we've got. Let's have a look. Factors of minus 6 that multiply to be minus 3. Oh, that does factorise. It's dead easy. I don't need to check that. 2x minus 1, and I'm going to have x minus 3 and x plus 2. Awesome. Right, we then get onto this hence bit. It's a pretty awkward hence bit, but we need to use a bit of intuition here. If it says hence, we are going to use something similar to what we've already had. We have already played about with the equation 2x cubed minus 3x squared minus 11x plus 6. If we look at what we've got 2 times 8 to the power of something, minus 3 times 4 to the power of something, minus 11 times 2 to the power of something, plus 6. You should have played with powers enough now to realise that 2 and then 4, well 4 is 2 squared and 8 is 2 cubed, so we actually have sort of a hidden cubic. So what we could do is you could then say something like, if I have 2 times 8 to the y minus 3 times 4 to the y minus 11 times 2 to the y plus 6 equals 0. And I make a substitution, something like let x equal 2 to the y, then you get 2x cubed minus 3x squared minus 11x plus 6 equals 0. And then you get, from the hence bit, 2x minus 1, x minus 3, x plus 2 equals 0. And then we can use those results, so therefore x equals a half, x equals 3, or x equals minus 2. Then we can pop back what we had, so 2 to the power y is a half. So you should recognise then that a half is 2 to the power minus 1, so y is minus 1. We got 2 to the power y is 3. That's a bit more complicated. So let's take logs. So y ln2 is ln3. You could have used log 2 if you wanted, but I just prefer ln. So ln3 over ln2, ln3 divided by ln2, slightly fewer button presses. So y is 1.5, what's it say? It doesn't say exact solution, so I've got that, or I've got, this is 1.58. And there are no solutions because 2 to the power y is minus 2. There are no real solutions here. You can't take logs of a negative number, so there are no real solutions. Right, question 5. Question 5. The graph of the function y equals f of x passes through the point P with coordinates 2, 6 and is a one-to-one function. State the coordinates of the point corresponding to P on each of the following curves. Okay, so on this first one, it is outside the function, it is adding and subtracting, so that means we're going to add 3 to our y coordinates, so that is just going to be 2, 9. The next one, what are we going to do? Now, the order matters on transformation of graphs when I've got multiple transformations. So I have got to do, if I start with f of x, and I then replace x with x minus 1, I'll get that, and then I replace x with 3x, I'll get that, and then I multiply by 2. If I did it the other way around, if I did 3 first, I would then have to replace 3, so I'd have f of x to start with. If I did the 3 first, I would have f of 3x, because I replaced the whole of the x with 3x, and then I'm going to replace the whole of the x, and this would have to be x minus a third to expand out and get the right thing. So it's going to be the translation first, and then it's going to be the stretch. So what's happened to my x coordinates then? So first job, when I translated 1 to the right, so that has become 3, 6. Then I have multiplied by 3 inside, so I'm going to divide by 3, so that is going to be 1, 6. And then I'm outside, so I'm going to do it to the y coordinate, and I'm going to multiply by 2, so that is going to be 1, 12. Y is the inverse function, so the inverse function is a reflection in the line y equals x, so that means this is going to be 6, 2. The diagram shows part of the graph of g dashed of x, so this is a gradient graph. The graph intersects the x-axis at x equals -2 and x equals 4. State the x-coordinates of any stationary points on the graph of y equals g of x. Well, a stationary point is when your gradient is 0, and this tells me what the value of my gradient is at particular points. So we know at -2 the gradient is 0, at 4 the gradient is 0, so that one, x is -2 or x is 4. State the set of values of x for which y equals g of x is a decreasing function. So a decreasing function is where my gradient is negative. So the only place on this graph where my gradient is negative is where x is less than -2. State the x-coordinate of any points of inflection on the graph y equals g of x. Well, that is the point x equals 4, because I have a 0 gradient, I have a stationary point, but I don't change whether I am increasing or decreasing either side of it. So that is that x equals 4. That looks horrible, but it was actually quite nice. Question 6 then. Question 6. Find the first 3 terms in that expansion in ascending powers of x. Right, we have got 8 minus 3x to the third. To use our formula from the formula sheet, we need to make this say 1. So the first thing I'm going to do is take a factor of 8 outside the brackets. So I'm going to take 8 out, and I'm going to have 1 minus 3/8 of x, and that's all to the power third. That power third can be applied to both of those things in there, so that could also be 8 to the third, 1 minus 3/8 x to the third, which 8 to the third cube root of 8 is 2 lots of 1 minus 3/8 of x to the third. So this is going to be 2 lots of 1 minus nx, sorry, 1 plus nx. So I'm going to have 1 plus a third, and then I'm going to have minus 3/8 of x plus n minus 1 over 2 factorial x squared plus all the rest of it. So what's that going to be? 2 lots of 1, and then I'm going to have minus an 1/8 x. What am I going to have here? The 2/3 on the bottom of the fraction are going to cancel with the third squared, 3 squared on the top of that one. 2 is going to cancel with the 4, so I'm going to have the minus 3/8 is going to be positive. I've got negative again, so I've got 1 negative going on. And I think I'm going to have 3, 3 and 3 are gone, 2 and 4 are going to gone. That's going to be over 4, and then I've got the 2 factorial, that's another 2, so I think that's going to be an 1/8 x squared. I don't know why I'm being lazy, let's just double check that. So let's have brackets. I've got a third. Let's make sure, let's do this properly. So I've got a third minus 1. Let's calculate to do the strain, make sure I've got that right. I've got 2 factorial on the bottom, so that's 2 shift. Factorial is, I've lost it there. And then I'm going to have open brackets minus 3 over 8 close brackets squared. Oh, that was very wrong. So that's going to be minus a 64th. It's a good job I checked, really. Minus a 64th. Let's just double check the first one then, just to make sure that we're right. So let's get rid of that power. Let's turn that to power 1. Let's go. That can be 1 factorial. Doesn't matter. And then we're going to get rid of this one. Okay, I was right on that one. So I am going to get 2 minus 2 over 8, that is a quarter, x minus 1/32 x squared. Right, state the range of values for which the expansion in part A is valid. So the this is valid for, as ever, the modulus of 3/8 x is less than 1, so x is less than 8/3. That's a standard one. Find the coefficient of x squared in the expansion of, well, that top is what we've just done, so the bottom then is, let's just write this down. So we are going for x squared in 8 minus 3x to the third over 1 minus 2x. 1 plus 2x squared. Okie. So let's get a full page. So this, we could rewrite this as 8 minus 3x to the third multiplied by 1 plus 2x to the minus 2. We want the x squared term, so what are we going to need from that? We're going to need the x term, we're going to need the x squared term, and we're going to need the coefficient term. So we need the first 3 terms from this. So 1 plus 2x to the minus 2 is going to be 1 plus nx, so that is minus 2, 2x, plus minus 2 minus 3 over 2 factorial 2x all squared, which is 1 minus 4x. The 2 and the 2 factorial are going to cancel out, so I've got positive 3 times 4, so that's going to be plus 12x squared. So once we've got that, then we can then say that we have got this 8 minus 3x all to the third, 1 plus 2x to the minus 2 is equal to, so what do we have before? 2 minus a quarter x minus a 32 x squared plus a whole bunch of stuff multiplied by 1 minus 4x plus 12x squared and a bunch of stuff after that. If we want the x squared term, we don't need to multiply it all out, but I'm going to need the 2 from that one multiplied by the 12x squared in that one. I'm going to need the minus a quarter x in that one and the minus 4x in that one. And then the last place I can get an x squared from is that minus 32 multiplied by 1. That's not the best colour. We're going to go with it anyway. So I'm going to have 2 times 12. So this is my x squared term. 2 times 12 plus minus a quarter times minus 4 plus minus 1 over 32 times 1. Is that going to be, so 2 times 12 plus minus a quarter times minus 4 plus minus 1 over 32 times 1, which is 799 over 32. That's a really vile number and would make you question your answer if you're doing that in an exam. This is not a nice paper. All right, we are halfway through. Let's see what is next. The curve y equals x squared minus 2 multiplied by ln x has one stationary point which is close to x equals 1. So the x coordinate of this stationary point satisfies that equation. I see the word stationary point. I'm going to differentiate. I've got two things multiplying together, so that's the product rule. So let's make u equal to x squared minus 2, and v is ln x. du by dx then is 2x. dv by dx is 1 over x. So therefore, dy by dx is x squared minus 2 over x plus 2x ln x. And then, if it's a stationary point, that's going to be equal to 0. So I can then multiply through by that x, and I'm going to get x squared minus 2 plus 2x squared ln x equals 0 as required. Show that the Newton-Raphson iterative formula for finding the root of the equation in part A can be written in that form. So that looks pretty vile to me. We want to find solutions to that. So if we go back to our Newton-Raphson, you'll find we need to differentiate again. So let me just copy this down from the formula sheet. So Newton-Raphson is there. So Newton-Raphson is xn plus 1 is xn minus f of xn over f dashed of xn. So let's go back to our formula. So this means that we need to differentiate that again. So we've got that f of xn is equal to what we've just worked out. So that's your x squared minus 2 plus 2x squared ln x. If we want to differentiate that, I'm going to get 2x, minus 2 is going to disappear, then I have to do a product rule again, so u is 2x squared, v is ln x, du by dx is going to be 4x, dv by dx is going to be 1 over x, so therefore I'm going to get plus 2x squared over 1x, so that's just going to be 2x, plus 4x ln x. So, what have we got? This Newton-Raphson formula then, x n plus 1, is therefore going to be xn minus xn squared minus 2 plus 2xn squared ln xn all over 2xn plus, no, we can simplify that to be 4xn, 4xn plus 4xn ln xn. Let's add together that, so I'm going to have to find common denominators here, so this is going to be xn 4xn plus 4xn ln xn minus xn squared minus 2 plus 2xn squared ln xn all over 4xn. I can factorise that, which is what it wants in the question. And then I've got ln xn plus 1. So the bottom is good. Let's just play about with this. So we're going to expand that. So I'm going to have 4xn squared take away another xn. So that's going to be 3xn squared. I'm going to have plus 4x squared ln xn, and then I'm going to have minus, because I really should have a bracket around all that, minus 2xn squared ln xn. So that's just going to be, so 4 of them, take away 2 of them, that's going to be plus 2xn squared ln xn. Yeah, and that's all of that. And then I've got minus 2, that's going to be plus 2 over 4xn ln xn plus 1. Right, so we've done that. Apply the Newton-Raphson formula with initial value x1 equals 1 to find x1 and x2. So x1 equals 1. So that's where we're going to go. 1 equals, and then we're going to have fraction line 3 times answer squared plus 2 answer squared ln answer plus 2 over 4 answer brackets ln answer plus 1. I just need to close that bracket. I need to open that one, close that one, sorry. So x2 is 1.25. Again, wouldn't use 5 over 4 because that implies it's an exact answer, and we know we're not going for one. Do it again, and I'm going to get x3 is 1.207515.437. Doesn't ask me to do x4, but it does ask me to find the values of the stationary point, giving each coordinate correct to 3 decimal places. So I'm going to continue doing this until I find an answer that matches to 3 decimal places. So x4 is 1.206, and then x5 is also 1.206. That matches to 3 decimal places. I'm happy with that. So I then want to find the coordinates of the stationary point, so I need to go all the way back to my initial y value of the curve, which was x squared minus 2 ln x. So I'm going to use that value I've just got, might as well, and we're going to have brackets answer squared minus 2 ln answer. Gives me a y value. 1.206 minus 0.102. Right, moving on to question 8. Functions f and g are defined for 0 to 2 pi for 2 tan x and sec x. State the range of f. Well, tan x can take all values of y. It has no limits on it. So we could just say then that the range of f of x is that f of x can be all real. The range of g, so this is sec x. So this is g of x is, what does sec x do? So that's cos. So cos does that. So sec does that. Okay, so cos can't be between 1 and minus 1. So g of x has got to be greater than 1 or is u, or g of x is less than minus 1. Show that f of g of 0.6 is 5.33 correct to 3 significant figures. So this means we are doing g first and then we are doing f. So g of 0.6 is 1 over cos of 0.6. So let's make sure we are in radians. We are. I can see the little r on my calculator, and I'm going to have 1 over cos of 0.6. So that gives me that. So therefore, f of g of 0.6 is going to be the same as doing f of 1.21, which is going to be 2 tan 1.21. So we're going to do 2 times tan of that answer, and that is 5.33 correct. It's just 3 significant figures. Right, explain why f of g of that is not defined. Well, f of x is a, which way around is it? So f of x is 2 tan x. So it does that. So f of x is a many to one function because many inputs will give the same output, because I'm going to get the same. If I go to that input and I go to that input, both of those will give me the same output. So f of x is many to one, so has no inverse. Right, we then get solve the equation f of x squared plus 6g of x equals 0. So that's going to be trig identities. F of x squared, so that is saying we have got 2 tan x squared plus 6 sec x equals 0. So 4 tan squared x plus 6, let's have that as over cos x equals 0. Let's rewrite tan squared as 4 sine squared x over cos squared x plus 6 cos x equals 0. Let's multiply through by cos squared, get it off the bottom. So I'm going to have 4 sine squared x plus 6 cos x equals 0, and then sine squared is going to be 1 minus cos squared, so that's 4, 1 minus cos squared x plus 6 cos x equals 0, so 4 minus 4 cos squared x plus 6 cos x equals 0. It says detailed reasoning. What that means in this situation is just don't whack it straight in the calculator, because some calculators can do that straight off. We're going to get to there. I'm not going to worry too much about the fact that I'm going to cheat and get my equation sorted for me. So my polynomial is degree 2. I've got minus 4 on my cos squared. I got 6 cos, and I got 4 on the end. I am going to get then that cos x minus 2 is a factor, and then I'm going to get 2 cos x plus 1 is a factor. So therefore I'm going to use the results that I just had. Cos x is 2, or cos x equals minus a half. Cos x equals 2 has no real solutions. So cos x equals a half. Well, let's do that then. So I'm going to go back to number 1. I want inverse cos of minus 0.5 is 2/3 of pi. And then let's look at what our cos looks like. Minus a half is there, so I'm going to be 2/3 of pi in from the from 2 pi. So let's do 2 pi minus the answer. I'm going to get 4/3 of pi as my solutions. Right, question 9. A particle moves in, what's that? A particle moves in the xy plane. So there are time t seconds, its coordinates are given by that. We have this parametric equation. Explain why the path of the particle never crosses the x-axis. Well, that's because e to the t is greater than 0 for all t. Therefore, e to the 2t minus 4 e to the t plus 3. Well, we've got e to the 2t is going to be 1. So rather, at t equals 0, we are going to have 1 minus 4 plus 3 equals 0. So it starts at the axis, and then e to the 2t gets bigger. And that gets bigger twice as fast as 4e to the t. So y, hold on, if it never crosses the axis, I'm looking at the wrong one. If it never crosses the axis, that's where my x coordinate is. If it never crosses the axis, e to t is greater than 0 for all of them. So what we can then say is then if y equals 2e to the minus 3t. In fact, if I put a k on there as well, that would just take into account the fact that I've got the minus 3 on there. So y equals 2e to the minus 3t. Well, that is greater than 0 for all t. It never crosses the axis. Determine the exact value of t when the path of the particle intersects the y-axis. So if it intersects the y-axis, that means the x value is 0. So we can make e to the 2t minus 4e to the t plus 3 equals 0. That's a hidden quadratic. So I'm going to have e to the t. I want two things that multiply to be 3 and add to be minus 4. So that's going to be e to the t minus 1 and e to the t minus 3 is 0. So therefore e to the t equals 1 or e to the t equals 3. So t equals ln1, which is 0, or t equals ln3. Right, we want to show that dy by dx, so we need to differentiate this parametric equation. So we know dy by dx is dy by dt times dt by dx. So let's find those things. So dy by dt is going to be minus 6e to the minus 3t. dx by dt is going to be 2e to the 2t minus 4e to the t, and the plus 3 disappears. So then dy by dx is going to be minus 6e to the minus 3t over 2e to the 2t minus 4e to the t. Right, so we need to change the format of this. Okay, so we can divide everything by 2. If we divide everything by minus 2, I'm going to switch the order of the bottom, get rid of the negative on the top. So that's going to be 2e to the minus 3t over 2e to the t minus e to the 2t. I can then rewrite that e to the minus t as 2 lots of 2e to the t minus e to the 2t times e to the minus 3t, and that we can actually think of as 1 over e to the 3t, and that's going to multiply by the two things on the bottom. So we're going to get 2 over 2 e to the 4t minus e to the 5t, which is what we had in the question. Hence, find the coordinates of the particle when its path is parallel to the y-axis. So if it is parallel to the y-axis, I have a set of axes there. If it's parallel to the y-axis, that means my gradient is going to look something like that. It's going to be a vertical line. So if I'm going to have a vertical line, that means I have an infinite gradient. So that means the bottom of my gradient is equal to 0. So therefore, we can say 2e to the 4t minus e to the 5t equals 0. We can take a factor of e to the 4t out. We've got 2 minus e to the t is equal to 0. And then e to the 4t is never 0. So e to the 4t is greater than 0, but 2 minus e to the t can be 0. So 2 is equal to e to the t. So t is ln 2. If t is ln 2, that means, let's substitute that back into our coordinates. So I've just lost them off screen, so let's write them down again. X is e to the 2t minus 4e to the t plus 3. Y is 2e to the minus 3t. So ln 2, so that's going to be e to the 2 ln 2, so that is 4 minus 4e to the ln 2 plus 3, so 4 plus 3 is 7, that's going to be 8, that's going to be minus 1, and then my y coordinate is 2e to the minus 3 ln 2, so minus 3 goes in, so that's ln 8, ln an 8th, the ln and the e cancel out, so that is going to be minus, no, it's going to be 1 over 4, not minus, it's just going to be 2 over 8, which is just a quarter. So therefore, I get those coordinates, which are just off screen there. Minus 1 and a quarter. Right, that was question 9. Question 10. How are we doing for time? We're just about at the hour mark or so. So question 10. The diagram shows triangle ABC, perpendicular from C to AB meets AB at D. Explain why the length of CD can be written as A cos Y. Really? Right, by definition, we have cos Y. So something like cos of Y is adjacent over hypotenuse, and cos of Y, my adjacent is CD over A, so A cos Y is CD. That was a really weird question. Obviously, the pandemic meant that exam writers couldn't write exams. Show that the area of triangle ADC, that is the left-hand triangle, is given by half AB sine x cos y. Right, so what do we know? Well, the area of a triangle is half AB sine C. So half, then two sides, and the angle between them. The angle between them is x, so that's going to be side x. We have then got side A is going to be the side that's actually labelled B, which is irritating because that's the side AC. So I've got half AC dot CD dot sine x. Dots just meaning multiply. So AC is B. CD we've just worked out is A cos Y, and then sine x. I'm pretty sure that's what we've been given, what we'd had a minute ago. Let's just make that a bit neater. So we've got half AB sine x cos y. Half AB sine x cos y. Hence or otherwise, show that sine of x plus y equals sine x cos y plus cos x sine y. Hence or otherwise. How am I going to show this? Right, well, what have we got? Well, we could look at this in terms of the sine rule, because you could say sine of x plus y over AB. That's not going to work. Hence or otherwise, show that this. So this is the area of just ADC. So I suppose we could do it the other way round. Find the other side of this triangle and say that CD is also B cos x. Yeah, that would work. B cos x. And then you could find the area of the other triangle. So area oh, this is going to work. And then find the area of CDB. So area CDB is going to be half a B cos x sine y. And then your total area is going to be half a B sine x plus y. I think we might just be proving the double angle formula here. Not that one. Half AB sine x plus y. And then you can say that that area sine is a half AB sine x, there it is, cos y plus a half AB cos x sine y. Let's do it the right way around. Cos x sine y, the half AB's cancel out. So therefore, sine x plus y is sine x cos y plus cos x sine y. That was revolting as well. There's a lot on this paper not to like. Hence or otherwise, show that sine, I've just done that, given that sine of 30 plus alpha is cos of 45 minus alpha, show that tan alpha is 2 plus root 6 minus root 3 minus root 2. So this feels like some double angle stuff. So we've got sine of 30 plus alpha is cos of 45 minus alpha. So we know from the equation, the formula we've just come up with, that the sine of that is sine 30 cos alpha plus cos 30 sine alpha. Is equal to, let's just double check the cos compound angle formulae. Let's go all the way back. So it's that one there, so that's cos A, cos B, minus, so this would be plus, sorry, so this would be cos, I'll write this down while it's on screen, so cos 45, we've got minus alpha, so this would be plus cos alpha, cos beta, so that's cos alpha plus sine 45 sine alpha. Let's go back to where we were. Oops, that one. Sine 30 is a half, so that is cos alpha over 2. Cos 30 is root 3 over 2. Cos 45 is the same as sine 45, which is root 2 over 2. Then we're going to have, same again, root 2 over 2. I can multiply the whole thing by 2, bring the cos stuff over, so I've got cos alpha minus root 2 cos alpha is equal to, same on this side, root 2 sine alpha minus root 3 sine alpha. Let's take factors out, so I've got cos alpha 1 minus root 2 is equal to sine alpha root 2 minus root 3, divide by cos, divide by root 2 minus root 3, so 1 minus root 2 over root 2 minus root 3 is sine alpha, oops, it's just gone off screen, sine alpha over cos alpha. That's obviously tan alpha, which is good. So I'm going to get 1 minus root 2 over root 2 minus root 3. Let's rationalise that, so that'll be root 2 plus root 3 over root 2 plus root 3. So what are we going to get? 1 times root 2 is root 2. 1 times root 3 is root 3 minus 2 minus 2 root 6 all over 2 minus 3, which is minus 1 on the bottom. So if we change all the signs on the top, we are going to get that tan alpha is 2 plus root 6 minus root 2 minus root 3, which is exactly what we want. Yep, that's exactly what we want. Question 11, 12 marks. Let's have a look. Use substitution u squared equals x squared plus 3 to show that that equals that. Okay, let's do that. So u squared is x squared plus 3. First thing you need to do is to differentiate that. So I'm going to get 2u du by dx is 2x. So u du is x dx. Probably useful. I'm going to rearrange the top because I think I'm going to get an x squared in this. So let's make that top be x squared is u squared. Take 3. So then I think I'm going to get, so we have the integral of 4x cubed over, well, that's root u squared. If I take one of the x's from the x cubed, I can get integral 4x squared u du over u. That u and that u are going to cancel out. And then I'm going to get, I told you I'd get an x squared, so that's going to be, 4 can come out, integral x squared is u squared minus 3 du. And that's a nice easy integration to do. So that's 4, and then we're going to go u squared is going to go to u cubed over 3 minus 3u. It's going to be plus c, but I'll deal with that in a bit. So that's going to be 4 or u squared. So that's going to be 4 lots of that's u cubed. I've got u squared. Put back. It's not mega useful. I'm going to need a u in a minute though. So that u squared is going to be x squared plus 3 multiplied by root of x squared plus 3 minus 3 root x squared plus 3, and that's over 3. What can I do? I'm not a big fan of this. I think feeling like I'm going to get different to 2 squares somewhere. So let's take the over 3 out. So that's going to be 4 over 3. That's going to be x squared plus 3. I'm going to get root x squared plus 3 minus 9 x squared plus 3. We're going to go 4/3 x squared root x squared plus 3 plus 3. Aha, there it is. Plus 3 x squared plus 3 minus 9 x squared plus 3, which is 4/3. Oops, that's slightly off screen. Which is 4/3 of x squared root x squared plus 3. Then I've got plus 3 minus 9, that is minus 6 root x squared plus 3. Not a difference of 2 squares at all. I can factorise the x squared plus 3 back out, so I'm going to get 4/3 x squared minus 6 x squared plus 3, and of course I need a plus c on the end. So the graph shows part of the curve, y equals that we've already done. Find the exact area enclosed by the curve, y equals this. The normal to this curve at the point 1, 2, and the x-axis. So a normal is going to come off at right angle, so it's going to look something like that. So that's going to be a lovely triangle. So that's 1, that's 2. So I think the first thing we can do is find this yellow section that I'm just going to colour yellow now. And that area is going to be, so that yellow area is the integral between 0 and 1 of 4x cubed over and that is what we had before. So that is with 1 in it. So I got 4/3 1 squared, I suppose, minus 6 root 1 squared plus 3 . Yep. Which is minus 40 over 3. Minus, let's pop the zeros in there. Minus 8 root 3. So times that by minus 1. And then we want to subtract 40 over 3. So that area is positive. Minus 40 plus 24 root 3 over 3. Okay, cool. Now we need to find the equation of the tangent. So we need to find the gradient of the tangent, and we need to find the gradient of the normal, and then we need to find where the normal hits the x-axis so that we can find this distance, so we can just find the area of a triangle. So let's find the gradient of the tangent. We are going to differentiate that. So if y is 4x cubed over root x squared plus 2, that's a quotient rule. So u is 4x cubed, v is root x squared plus 2. du by dx is 12x squared. dv by dx, that's chain rule. So we're going to do the differential of the inside, so that is 2x. And then we're going to do multiplied by the outside differentiated. So if it's u to the half, that'll be half u to the minus half. So that'd be over 2x squared plus 2. So the 2's are going to cancel out. So that's just x over root x squared plus 2. I can never remember the order for quotient rule, so let's just make sure I get it the right way around. The quotient rule is on the bottom there, the middle of the first page. So I have got dy by dx is v du, so that is v du, so that is 12 x squared root x squared plus 2 minus 4x cubed x root x squared plus 2, and that's all over v squared, so that's just x squared plus 2. Right, I've written that down. We'll be able to just use that. So that's just there. I am no way going to try and tidy that up. I'm just going to fire in my x coordinate, which is 1. So we've got the big one in the middle. We've got 12 times 1 squared. And then I've got root 1 plus 2. I'm not bothering putting squares on because it's 1 minus 4 times 1. So that's 4 brackets 1 over root 1 plus 2. And then I've got all that is 1 plus 2, which is 3. So that is 32 root 3 over 9. So therefore, the gradient of the normal is minus 1 over that. So minus 1 divided by the answer is minus 3 root 3 over 32. So therefore the equation of the normal, so y minus, it goes through 2, so y minus 2 is minus 3 root 3 over 32 x minus 1. We want to find a y coordinate when an x coordinate when y is 0. So I've got minus 2 is minus 3 root 3 over 32 x minus 1. So I'm going to have minus 2 divided by that answer gives me 64 root 3 over 9 is x minus 1. So x is, I need to plus 1 to that. 9 plus 64 root 3 over 9. So if we go back to our diagram, that means this is 9 plus 64 root 3 over 9. So therefore the area of the triangle is base times height over 2. Now the base is 9 plus 64 root 3 over 9. Take 1. Well, we know when we added 1. Before we added 1, sorry, we had 64 root 3 over 9. So my base is 64 root 3 over 9 times 2, all halved, is the triangle. So the area, the total area, is minus 40 plus 24 root 3 over 3 plus 64 root 3 over 9. So we are going to get minus fraction 40 plus 24 root 3 over 3 plus 64 root 3 over 9 is... What a vile looking answer. This has been a horrible paper. minus 120 plus 8 root 3 over 9. That is revolting. Right, last question. A cake is cooling so that T minutes after it is removed from an oven, its temperature is theta degrees C. When the cake is removed from the oven, its temperature is 160. After 10 minutes, its temperature has fallen to 125. In a simple model, the rate of decrease of the temperature is assumed to be constant. Write down a differential equation of this. So, d theta by dt is d theta by dt is just minus k. It's the rate of change is a constant. Solve this differential equation to find theta in terms of t. So d theta is minus k dt. Integrals on both of them. Theta is minus kt plus c. We know initially, so when t equals 0, we know that theta is 160, so 160 is equal to c. When t equals 10, theta is 125, so 125 is minus 10k plus 160. So 125 minus 160, 125 minus 160 is minus 35, divided by minus 10 gives me minus 3 over 2, or minus 3.5, sorry. So k is 7 over 2. So this is theta is minus 7 over 2t plus 160. State one limitation of this model. The model will predicts cake will freeze, which we know from living in the world that it won't. It'll just get down to room temperature. In a revised model, the rate of decrease of the temperature of the cake is proportional to the difference between the temperature of the cake and the temperature of the room. Now this is more like what I'm expecting. The temperature of the room is a constant 20 degrees C. Right, then a differential equation for this revised model. So this is what we are expecting. D theta by dt. So the rate of change, the rate of decrease is minus k, that's proportional, the difference between the temperature of the cake, theta, minus theta naught. Theta naught I can actually put in as 20. So write down a revised model for the cake. So what we're going to have, separation of variables, so we're going to have 1 over theta minus 20 integrated d theta is minus k dt integrated. Really common integral, this one. So this is going to be ln theta minus 20 is equal to minus kt plus c. Then when we take logs, we're going to get theta minus 20, whoops, not 2 theta. Theta minus 20 is equal to ae minus kt. Again, super common way of getting that, of changing this. You take e of both sides to get rid of the ln. E to the minus kt plus c, and then of course you have, that is e to the minus kt times e to the c, e to the c is constant, so it just becomes a new constant, capital A. Again, we have the same initial conditions. We have, what is it, that theta is 160 when t is 0, and we have theta is 125 when t is 10. So we're going to use those to find out our values of A and K. So let's do when t is 0, so I've got 160 minus 20 is, when t is 0, e to the minus kt is 1, so that's that. So A is 140, and then I'm going to have a value for A. We now need to find a value for B. So we are at the point where we can now say that theta minus 20 is 140 e to the minus kt. We've got the value of 125, so I'm going to do 125 minus 20 over 140, and I'm going to ln that is equal to minus 10k. So that therefore means k is, what's this, ln, we've got in there, we've got 125 minus 20 over 140 divided by minus 10 gives me k is 0.0287. That's 0.029. So therefore, we've got theta equals 140 e to the minus 0.029 t plus 20. We then get told the cake can be decorated when its temperature is 25 degrees. Find the difference in time between when the two models would predict the cake can be decorated, giving your answer correct to the nearest minute. So the first one is, so this is part C, theta is minus 7 over 2t plus 160. So let's make that 25 degrees. Where's that gone? Why has that not come through? Let's try that anyway. It'll come through in a second. So I've got 25 equals minus 7 over 2t plus 160. There it is. 20, and we can rearrange that. So 25 minus 160 is that divided by minus 7 over 2 is 270 over 7, or 38.6 minutes, 39 minutes. So t is 39 minutes. The other one, we're going to have 25 is 140 e to the minus 0.029 t plus 20. So that's going to be 25, take 20 divided by 140, and then I'm going to ln that, so ln that, and then I'm going to divide that by minus 0.029, giving me that t is 115 minutes. So therefore, the difference is that answer, take away 38.6, which is 76.3, which is very slightly wrong according to the mark scheme, so I've probably done too much rounding, but I think that's good enough for now. It was a November paper. They get what they get.